Okay, chapter 6 is titled Efficient Diversification. In this chapter, we're going to evaluate a two-security portfolio, and this is going to build on the analysis we did in chapter 5 with a single risky security. We're going to have two risky portfolios. Specifically in this chapter, we're going to have a bond and a stock portfolio. So diversification and portfolio risk. So first thing we're going to talk about is market or systematic risk. Market or systematic risk is thought basically is non-diversifiable. Means that we cannot diversify that risk away no matter how many stocks we add to our portfolio. So we can't diversify these risk factors that are common to the entire economy. However, we can diversify away firm-specific or unsystematic risk. So this risk can be eliminated through diversification. So by adding a sufficient number of stocks, we can virtually eliminate this type of risk. So next two charts are going to show how that is done. So figure 6.1 shows firm-specific risk in the first chart. On the left-hand side here, we've got standard deviation and firm-specific risk are not graphed against number of stocks. So so we can see as we add stocks, that firm-specific risk virtually goes away. There's still a small amount left, however, it goes away considerably. The next chart, same setup, standard deviation on the y-axis and number of securities on the x-axis. But in this case, we've combined the market or systematic risk with our unique firm-specific or unsystematic risk. So, and we can see as we add securities, the diversifiable risk goes away and there's virtually no impact on the market risk. Figure 6.2 adds numbers to the analysis, and we can see that again we have both. We have all risk here. We have market risk and firm-specific risk, and we start out around 27%. And then as we add securities and get up to around 30 securities, we're able to diversify away the vast majority of that firm-specific risk. Again, however, we're not able to diversify away the market risk. So in order to do this, we need to do some calculations. So covariance and correlation are part of the statistical analysis that we'll do to develop our optimal portfolios. So portfolio risk depends on the correlation, the covariance between the returns of two assets. The best thing that you can have between two assets is a negative covariance or negative correlation. If they are, this will tend to reduce the risk. And for example, stocks and bonds have historically been very good counterparts in a risky portfolio because stocks tend to do well when bonds do poorly and vice versa. So as a result, this tends to smooth out returns. However, this has been much more difficult in recent history because the interest rates have fallen to such low levels. Expected return on a two-security portfolio is simply the expected return of the portfolio is equal to the weight in the first asset multiplied by the expected return in the first asset plus the weight in the second asset multiplied by the expected return in the second asset. So the explanations down below here. So move on from the expected return, now we have to calculate the covariance. Covariance, in this case, this is our stock and bond portfolio. The covariance over expected return on stocks and the expected return on bonds simply equal to the summation, the probability multiplied by the expected return, subtracted from, multiplied by the expected individual return, subtracted from the expected return for all outcomes, and then each individual expected return subtracted from the calculated expected return. So what we're going to do, so in our example, we're going to have 4 possible outcomes. So we'll have 4 probabilities. And then we'll have 4 returns for stocks and 4 returns for bonds. And then we'll calculate the expected return for those 4 possibilities. Then we'll calculate this covariance based on the information that we have. And again, we're going to walk through this calculation step by step based on the charts that we'll see later in the chapter. Correlation coefficient is simply, it's denoted by rho right here. It's rho SB would be the correlation coefficient for this portfolio. So it's the covariance of the return on stock and return on bonds, so what we calculated up here, divided by the 2 standard deviation, the standard deviation for stocks, standard deviation for bonds, multiplied together. So we can rearrange this equation, and we can also, if we have the correlation coefficient, we can calculate the covariance by multiplying it by the standard deviation for stocks and the standard deviation for bonds.